Hello, 7th graders. As we continue to study linear equations and their graphs, here's today's lesson. Pretty specific. We're going to cover two situations that in our everyday lives are very, very natural. Vertical and horizontal lines are special in our everyday lives. We see them everywhere. We see them without even thinking about them. We look at a tree or a flagpole and it's vertical, unless we tilt our heads. Then it would look horizontal, I suppose. The word horizontal is actually the same as the word horizon. I'm not sure which came first, but we look out at we're at the ocean shore and we look out and we see where the sky and the ocean seem to come together, and it's a horizontal line. Again, unless we tilt our heads. Horizon, horizontal. So they're special in our everyday lives. We're going to see that mathematically the vertical line is actually more special than the horizontal line. The vertical line is in a class by itself for certain purposes, which we'll get to later. But the rule is this. When you have x equals a number, I've chosen k to represent any real number. Positive, negative, zero, fraction, integer, rational, irrational, any of the real numbers that you're familiar with. If x equals one of those numbers, x equals a number, we have a vertical line. And if y equals a number, we have a horizontal line. Now, the first thing we want to say here is, does it seem backwards? Well, I've really taught you this before. But when you first encounter it, it may very well seem backwards. The x-axis is horizontal. So it would be natural to think, well, if we have x equals a number, it's going to be horizontal like the x-axis. But no. Same thing with y. We see y equals a number. The y-axis is vertical. So we see y equals a number. We might think it's vertical, but it isn't. Now, when we look at the geometry of these two situations, we will see that it is this way because it has to be. It makes perfect sense once we start to look at it, even though at first blush it may seem backwards. So we will now look at the geometry of horizontal and vertical lines and how that geometry relates to the equation. That's always the big picture in this area. Make sure you see that the equation and the geometry, or the equation and the graph, are two sides of the same mathematical coin. Let's consider two equations in the form x equals a number. First, we'll look at x equals 3, and then we'll look at x equals negative 3. And we will attempt to graph these equations. We'll come up with the graph of each of these equations. Now, another natural thing for someone to do, when you see x equals 3, you might be tempted to go to the x-axis and put a point at 3. That makes sense. So I'll do that. And if we were only dealing with one dimension, if we were only on a real number line and that's it, not a plane like we have with the x and y coordinate plane, not if we were only in a one-dimensional universe, which is a line, that would be x equals 3. But in the two-dimensional universe, this is not the only place where x equals 3. This here is the point 3, 0. But what if we go one unit above it? That would be the point 3, 1, right? And if we were to go another unit up, that would be the point 3, 2. Now, I'm not going to draw the write the coordinates on the board here. I want to keep it clean, but 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and so on. And below the x-axis, we could put a point there. That's the point 3, negative 1. And then 3, negative 2, and 3, negative 3, and so on. And hopefully you see what's going to happen now. When you're in two dimensions, x equals 3 is a vertical line. Now, it does go through the x-axis at 3, but it goes through the plane at an infinite number of places along that vertical line. So let me just, without a ruler, I'm going to just quickly sketch it in here. And I will do the the number one most important thing in this area, I will say this. Every single point on this line has an x coordinate, which is 3. And the only place in this entire plane where x equals 3 is on that vertical line. This equation, x equals 3, and that vertical line are the same mathematical reality. Sometimes I use this sort of way of thinking about things. Imagine, if you want to say, well, x equals 3 is on the x-axis at 3, 0. Think of it this way. There's an infinite amount of ink at 3, 0, and we can stretch that ink out infinitely up and infinitely down to get that vertical line. If we were to stray either to the right or to the left off of this vertical line, x would no longer be 3. So then we wouldn't have that equation. We only have this equation, x equals 3, on that vertical line. And in a similar way, x equals -3, won't have to explain that as much, won't take as long, but I just do the same kind of thing through the point -3, 0, and then infinitely up and down from there so that we get this vertical line. This vertical line here, every point on this vertical line has an x coordinate of -3. And the only place in the plane where x equals -3 is on that vertical line. If we stray to the left or to the right, then the x is no longer -3. So this is how the vertical lines work. Let's consider a couple of horizontal lines now. I've written 2 equations on the whiteboard, y equals 4 and y equals -6. And once again, we might be tempted initially to say, well, where does y equal 4? Well, 4 units up on the y-axis. And this point here, 4, 0, the y does equal 4 there. But y also equals 4 everywhere along a horizontal line that goes through that point. So we could go 1 unit to the right, 1 unit, another unit to the right, 2 units, 3 units to the right, 4 units to the right. And we could do the same thing to the left. Okay? So now I've got a bunch of points that all have a y coordinate of 4. And I can sort of quickly sketch a line that's going to catch all of those points. All right? Every single point on this blue horizontal line has a y coordinate of 4. Points like 0, 4, 1, 4, 2, 4, 3, 4, 4, 4. And of course, the ones in between too, the ones with fractional coordinates. -1, 4, -2, 4, -3, 4, -4, 4. See a pattern there. The y is always 4. If we were to stray either up or down off of that horizontal line, then the y would no longer be 4. Every point on this blue horizontal line has a y coordinate of 4. And the only place in the plane where the y coordinate is 4 is along that blue vertical line. I'm sorry, blue horizontal line. This blue horizontal line and this equation y equals 4 are the same mathematical reality. The other equation, y equals -6, I think you've got the picture now. That is a horizontal line that goes through, it does go through the y-axis at -6. 1, 2, 3, 4, 5, 6 down like that. But it's also, y is also equal to -6 anywhere along that horizontal line. Couple of things before we close. First, we have 4 points of intersection here. And I said earlier that I wasn't going to indicate the coordinates on the plane to kind of keep things neat. But I'm going to do that 4 times. We obviously have 4 points of intersection. I'll put big black points there, okay, where these 4 lines that I've constructed intersect. Well, what are the coordinates of this point? Well, it's on the line x equals 3, and it's also on the line y equals 4. The coordinates of this point here are 3, 4. Now, you knew how to get to that before you ever considered vertical and horizontal lines. To get to this point, you go 3 to the right and up 4. But now you can see it as every point in the plane. You can see it as an intersection of a horizontal line and a vertical line. The horizontal, the vertical line gives you the x coordinate, and the horizontal line gives you the y coordinate. This point here is at the intersection of x equals -3 and y equals 4. So this point here is -3, 4. Okay? The x is -3 from the vertical line. The y is 4 from the horizontal line. And the same for the other ones. This point of intersection here, the x is -3, the y is -6. So this is the point -3, -6. And then over here, the x is 3, the y is -6. So this point of intersection is 3, -6. That might help you to appreciate these vertical and horizontal lines and their equations, to consider that every point in the plane can be considered the intersection of a vertical line, which is x equals a number, and a horizontal line, which is y equals a number. And one last thing, this might also help clarify things, make you very confident about this. And it kind of goes back to that original thing that I said, that it seems counterintuitive that x equals a number would be vertical and y equals a number would be horizontal. See, here's the x-axis, which is horizontal. Here's the y-axis, which is vertical. But this x here on the x-axis, that's not the equation of the x-axis. Let's call it its name or its label, but it's not its equation. There is actually an equation for the x-axis. What do you think it might be? Think about it. It's not x equals a number because the x-axis is horizontal. The x-axis is y equals 0. Everywhere along the x-axis, the y coordinate is 0. The x-axis is a horizontal line, so it has to fit into this scheme of y equals a number. And in a similar way, the y-axis, y is its name or its label, but that's not its equation. What is the equation of the y-axis? It's x equals 0. It's a vertical line, so it has to have an equation, x equals a number. Everywhere on the y-axis, the x is 0. So x equals 0 perfectly describes the y-axis. It's its equation. So this comes up a lot. When we continue to study linear equations and their graphs, remember this. X equals a number is a vertical line. Y equals a number is a horizontal line. That's all for now. Take care. See you soon.